Hello everyone, welcome to my channel. Today our topic is right circular cone from class 10 chapter 7. So let's get started. Now first, what is a cone? As given in the slide, a right circular cone is a solid generated by the revolution of a right angle triangle above one of the sides containing the right angle as axis. So the definition says, if you have a right angle triangle and if it rotates, so what happens is you get a cone shape. So that is what the definition actually says. So now let's go look at some real examples of a right angle circular cone. Look at the picture on the screen. You can see a birthday cap, an ice cream cone, a traffic cone, a carrot, yes, roughly a cone shape, hourglass, where the top and bottom are cone shapes. So cones are everywhere around us in daily life. Now that we know what a cone is and where we see it, let's learn the 5 important parts of the cone. Look at the diagram carefully. Number 1 is apex. This is the pointed top of the cone. The sharp tip at the top, we call it the apex. It is height. This is the straight vertical distance from the apex at the top to the center of the circular base at the bottom. We write it as small letter h. So next one is radius. So as we all know, the base of the cone is a circle. The radius is the distance from the center of the circle to its edge. We can write it as with a small letter r. So next one, number 4, slant height. Now this is very important. The slant height is the distance from the apex to any point of the edge of the base of the circle, but measured along the slanting side, not straight down. Next, the number 5 is base. So the flat circular face at the bottom of the cone, it's just a circle. So to summarize, the top point is apex, the straight height h, the base circle radius r, slanting slide, you can say it as slant height, and bottom face as base. Great. Let's move on to the next part. These are very important, not just for cone but for all solid shapes. So number 1, the base area. This is simply the area of the bottom face of the shape. For a cone, the base is a circle. So the base area is equal to area of the circle. So next is curved surface area. We write CSA. This is the area of only the curved part of the cone, like the outer skin of the cone, not including the base circle. It is also called the lateral surface area or LSA. So next we can go for the total surface area, which is TSA. This is the area of the entire surface, curved part plus the base. So the simple way to remember it is the total surface area is equal to CSA, that is the curved surface area, plus base area. So you can write it down for future reference. Okay, now we are on the most important part, the formula table. Look at this table carefully. You can note this as it's very important. Now let's understand the slant height formula. Look at the cone diagram. You can see 3 measurements. The height, which goes straight down from the apex to the base center, the radius, which goes across the base, and the slant height goes from apex to the edge of the base. Do you notice something? These 3 are right angle triangle. Height h is the vertical side, radius r is the horizontal side, and slant height is the hypotenuse, the longest side. And we know from Pythagorean theorem, hypotenuse squared is equal to the side squared plus again the side squared. So therefore we get this formula. Whenever I'll give you a hint, like the question gives you height and radius, use this formula to find the slant height first, then solve the rest. Now let's solve a problem. The radius of a conical tent is 7 meter and the height is 24 meter. Calculate the length of the canvas used to make the tent if the width of the rectangular canvas is 4 meter. So let's take a moment. It's about a conical tent, a tent shaped like a cone. They gave us the radius, which is r is equal to 7 meter, height is equal to 24 meter, and the width of canvas is 4 meter. They have asked us to find the length of the canvas. Now think about it. If you want to cover a cone with cloth, you need a cover. You have to cover the curved surface only, not the base. The base is on the ground. So first we need to find the curved surface area. To find the curved surface area, we need the slant height first. So first let's apply the slant height formula. They have just substituted the values given in the question. So 7 square plus 24 square, all that they have substituted, and by that we are getting the value 25 meter. So the slant height is 25 meter. So now let's find the area of the canvas, that is the CSA. So the formula for the CSA as given earlier is pi RL. So by substituting all that, we are going to get 550 meter square. So the canvas area needed is 550 square meters. Now to find the length of the canvas, as we know the canvas is a rectangle, so area is equal to length into width, where by substituting the values and calculation we are getting the length as 137.5 meter. Therefore the length of the canvas is 137.5 meter. So now let's solve another problem. If the total surface area of a cone of radius 7 centimeter is 704 centimeter square, then find its slant height. As given, the radius is 7 centimeter, TSA is 704 centimeter square, so we have to find the slant height. This time they have given the total surface area and they have asked for the slant height, so we can work backwards using the TSA formula. So the total surface area of the cone is equal to pi r L plus r. So by substituting all the values and calculating, finally we are getting it as 25 centimeter. That is, therefore the slant height of the cone is 25 centimeter. I hope this video was helpful for you. If you have any doubts, write them in the comment section below. Keep learning. Bye.